Hi everyone, welcome back to Addison Engineering Academy. It is still your lecture series on this topic, moment area method, and we're going to handle problem number 4. But before we continue, please don't forget to like, share, comment, and subscribe. So at this juncture, we are going to solve this problem that says find the support rotations, mid-span deflection, and maximum deflection in the figure below given. P is 5 kilonewton, L is 2 meter, and EI is 8,000 kilonewton meters square. Now, this question I'm going to solve in two parts. The first part we're going to handle support rotations, then mid-span deflection. Then in the second part, I'm going to handle this maximum deflection in the figure given below. Since this is moment area method, last time in my previous video I explained to you that there are two theorems. In the first theorem, it says the change in slope. The change in slope gives you the area under the M by EI diagram, meaning that I need to draw the M by EI diagram. So from this, I will first start by sketching what is called elastic curve. So here if I draw, this is how the beam is going to be deflected. So if I extend the tangent of this from here, I hope you can see it. Then I do the same, this if it is extended up to this point. Okay, so you find that if this is point C, then I will mark this point as C1, then this point as what? As C2. So this distance from here up to this point is called, I'm calling it tangent at B due to the original axis from A. This side I am calling it tangent at A due to line drawn from what? From B, due to these extensions. Please make sure you understand that. It's important for us. Now, here also, if you draw this at this point where it's maximum, and you draw this gives you tangent at point C. But due to the original line drawn from what? From A. It's very important, C1, C2. Then the next thing is that we need to draw moment diagram. A simply supported beam with center load at the center. The moment diagram is expected to be like this, okay? This is our M diagram, So M diagram, since this is P, so P by 2 times L by 2, when you divide, this side will be P by 2, this side is P by 2. So P by 2 times L by 2 is PL by 4. This is our moment diagram. But now we need to draw, most importantly, M by EI diagram. So what is going to be M by EI diagram? So for the first part, our I is what? 3I. Then this is only I, okay? So meaning that what I have here, I'm going to divide it by 3I for this portion. Okay? So this side, if I divide it by 3I, it will reduce to PL by 12 EI. Okay? Then for this side, if I divide by I only, it is going to be remain what? It is going to remain as what? As PL by 4 EI. Okay? So this is what we have. So this side is figure 1, and this side is figure 2. So from these diagrams, we can solve the questions. The question says support rotation. So in our previous videos, I told you that rotation at A can be found by, because I need rotation at A, which is what? This. So can be found by this one, which is TB here, B of A divided by L. Rotation at B the same way. Since I want this rotation at B, so it is going to be this side, which is TA of what? Of B divided by L. So what is the task? I need to find TB of what? A. So how do I find tangent at B due to what? Due to the original axis drawn from A. So this is the area between these 2 points multiplied with centroidal distance when you are standing at what? B. So B and A, there are two figures. First figure, this is M by EI diagram, okay? First figure and second figure. So starting from the first figure, the area is half times L by 2 times PL by 12 EI, okay? PL by 12 EI. Then centroidal distance, okay? What is our centroidal distance when you're standing from B? So when I'm at B, the centroid of this is somewhere here. So I need this distance, okay? I need the distance from here to here. So which is first L by 2, which is for the second figure, L by 2 plus the distance here. So if this is a triangle, how do you find the central? From this bigger side, it is 1/3 of L by 2. Then from this side is 2/3 of L by 2. So it is from this side, so it is 1/3 of what? L by 2. So I've found one for figure 1, so I have to add for figure 2. So figure 2, the same area, which is what? Half L by 2 times PL by what? PL by 4 AI, okay? 4 AI, because this is figure what? Figure 2. So multiply with the centroidal distance when you're standing at B. From B, what is the centroid of this? Bigger one, so 2/3. So this is 2/3 of L by what? Of L by 2, right? So if you simplify this one carefully, you'll find that T tangent at B due to axis drawn from A is going to be, so if you simplify this expression, okay, please verify that it is going to give me 5 PL cubed by 144 EI. Let me just confirm that if that is the case. Yeah, my calculator has given me that. So meaning that if I need to find rotation at A is going to be 5 PL divided by PL cubed out of 144 EI divided by what? By L. Okay? Divide this by L according to this formula, of which is going to be 5 times, what is my P? My P is what? Is 5 times, what is my L? Okay, remember this is now going to be L square. Okay, so what is my L? My L is given to be 2, so this is 2 square. So divide this by what? By 144. 144, then times what? EI. Here is 8,000. Okay, so what will be our final answer for rotation at A? So rotation at A, if you simplify this or press this from your calculator, mine is giving me 8.7 times 10 raised to power negative what? Negative 5. Since its rotation should be in what? In radians. Okay, so this is our answer for the first part. So we just take this and we do for the second part, that is for rotation at P. If this is clear, I can erase it. Okay, so now let's do for rotation at what? Rotation at B. Okay, so rotation at B is going to be tangent at what? This tangent A of B divided by L. So I need to find what? Tangent of A, B. So this is the same way. So area of figure 1, half times L by 2, then times PL by 12 EI, this is the area, times the centroidal distance. When I'm standing at point what? The first letter, A. When you're standing at A, what is the centroid of this first figure? It is 2/3 of L by 2. Okay? 2/3 of L by what? L by 2. Plus, second figure is, the area is half times L by 2 times PL, this is PL by 4 EI. Okay? Now, multiply it with the centroidal distance. Centroid of this one, when you're standing from A. The first part is L by 2. L by 2. Plus the second part, which is this, is 1/3. 1/3 of L by 2. Okay? 1/3 of L by 2. So don't miss that. So if you simplify this expression, this fraction, I believe it is quite easy to simplify it. Okay? You will get 7 PL cubed by 144 EI. Right? So if you want to find rotation at what? At B, you need to divide this by L. If you divide this by L, it will cancel one of the L. It will remain 7 PL what? Square by 144 EI. Okay? So given the value, if you substitute it, it's going to be 7 times P is 5 times L is 2 square divided by 144 times 8,000. Okay? Right. So if this is our value, if you press from your calculator, you're going to get 1.1. 1.1. Let me just check that. 1.21. I mean, yes, 1.21 times 10 raised to power negative 4. This is also in what? In radians. That is for the first part. Right, I believe that is quite clear. I will do the second part, which is mid-span deflection. It is quite easy if you know that the theorems we have discussed in the first video. You can apply it and easily you get the answer. Okay? So, second part, mid-span deflection. So, since I want mid-span deflection, that means I need a deflection at point what? C. And a deflection at point C is clearly shown on the elastic curve. It is the distance from this part C to C1. Okay? So that means deflection at part C is going to be equivalent to C1. Okay? And C1 can be got by total of this C2 minus C2. Okay? Remember the total from here up to this meeting point. Okay? So this is minus C1, C2. So I have a task. Can I find C2? So C2 from point A to this point, let me name it maybe O. A, O, then this is B. A, O, B, and A. This is a triangle, a big triangle, right? So half of this big triangle is the center, which is CC2. So that means half of TB of A is going to give you the answer you want. So what was the value of TB of A? Okay, we used it to find rotation at A, you remember? So it was 5 PL cubed by 144 EI. Okay? So when you divide this by what? By 2, it is going to give you the value of CC2, which in this case is 5 PL cubed by 288 EI. Right? Now, let us find the second part, C1, C2. So to find C1, C2, it is tangent at C due to the original axis drawn from A. Okay? So let's find that. Tangent at C due to axis drawn at A is equals to, since we learned how to find the tangent at C due to axis drawn from A, it's just the area between the two times the centroidal distance when you're standing at point what? C, the first letter. Okay? So this is going to give us half times the area between what? Between C and A is the first figure, because this is C. Okay? C and A. So the area is half times L by 2 times PL by 12 EI. Okay? PL by 12 EI times the centroidal distance. What is the centroidal distance when you're standing at first letter C? This is C. Okay? Centroid of this first figure is 1/3 of L by 2. 1/3 of L by what? L by 2. Okay? So, if you solve this carefully, C1, C2 value is going to come to PL cubed by 288 EI. Okay? So when I substitute this one here, both of them, I'm going to find deflection at C, which is going to be 5 PL cubed out of 288 EI minus PL cubed out of 288 EI. Okay? So these two, when you subtract it well, you're going to simplify it and you'll get what? PL cubed, okay, out of 72 EI. Please do confirm that. PL cubed out of 72 EI. So that's what we have. So I can now substitute the value of PL and EI to get the final answer. Can you erase this? Okay. So finally, deflection at C is going to give us PE, which is 5 times L, which is what? 2, but cube. Okay. Then out of 72 times EI, 8 what? 8,000. So what is your final answer that? If you press your calculator carefully, what are you supposed to get? Okay? So now, that final expression, let me just have my calculator, then we press it together. Okay? So this is 5 times 2 raised to power 3. Then divide this by 72 times 8 third. Okay? So the answer is 6.9 times 10 raised to power negative 5. Okay? 6.9 times 10 raised to power negative 5. This is deflection, so it's supposed to be in what? Meters. So this marks the end of our first what? Our first section, our first what? Part. So I'm going to explain for you in the next video our what? Second part. Please don't forget to like, share, comment, because this is the best explanation that you can get on this. So we shall do the second part, which is a maximum deflection, in our next video. Don't miss that. Thank you.